Hello and welcome to this video. I am Karnesh Jori and this video is about shell scripting. A shell script is a program written in shell's command language to automate a set of operations. For example, you want to give certain commands in succession and you need to do it quite often. Rather than type those commands every time, you can put the commands in a file, make the file executable, and that file becomes the shell script. Next time you want to execute those commands, you can execute the shell script. Let's look at an example. Suppose you have a directory structure on the remote system, My Site. Then you have a local system where you want to have an exact image of the directory /home/me/my site in your home directory on the local system. On the local system, you can give the commands cd $home/my site. This gets you in the home directory rsync -avz -delete user id at remote host my site dot. This should result in my site on the remote local system becoming an exact copy of my site on the remote system. Furthermore, I want to save a backup of my site in my backup directory. So I can give the command on the local system cd. This puts me back in the home directory tar-cvzf ~backup/mysite.tar.gz my site. I may have some more auxiliary commands. Now it's a hassle to remember and type all these commands correctly every time I want to take this backup. So I make a shell script in the directory src cd ~src vi back my site. So the first line is hash !bin/bash. This is the shebang and it tells the system that /bin/bash is the interpreter to be used, and I put those commands cd /home/me/my site rsync -avz -delete my user id at remote host my site dot. Then I go back one step backwards cd tar-cvzf /home/me/backup/mysite.tar.gz my site, and that's all in this file. Then I quit the vi editor and I make this back my script executable, and I can execute /back my site. Now every time I want to take backup, I can execute this script. Parameters and variables. Parameters store values and are identified by a name or number or certain special characters. A parameter denoted by name is a variable. A variable can be assigned a value with a statement like name is equal to value. For example, x is equal to 10. Here we must not leave spaces after x and before 10, because otherwise x is interpreted as a file name to be executed. So if we say echo $x, this prints 10. Rather than saying $x for printing the value of x, we can enclose x within braces and use the construct $x. Echo $x prints 10. We need to put braces around variable names to delimit the variable name in running text. For example, to is equal to 2, echo $today. This prints nothing, but echo $today, it prints the value of variable to followed by text day. As another example, t is equal to to, echo I will see you $t tomorrow, and it prints I will see you tomorrow. Quoting, we have seen that shell, and by shell we mean bash, deals with character strings. There are certain special characters which have a special meaning. For example, space means a delimiter and dollar starts usage of a variable. So in an assignment we say x is equal to something, and to print the value of x we need to say $x. The escape character for a special character is \. So we can say x is equal to hello backslash space world. Now X contains hello space world. Echo $x prints hello space world. Now Y is equal to $x echo $y. This prints the value of Y, which is the same as the value of X. But if we say Y is equal to backslash $x and echo $y, prints the value of Y, which is literally $x. The backslash has turned off the special meaning of the dollar character. Single quotes. We can preserve the characters of a string by enclosing it in single quotes. When we enclose a string in single quotes, shell does not look inside the string and the characters like dollar, space, backslash are left as they are. However, if you enclose a string in single quotes, there cannot be a single quote in the string. For example, X is equal to hello, echo $brace X prints hello. Y is equal to single quote $brace X world, echo $brace Y prints $brace X world. And if we try putting a single quote in a string, S is equal to hello backslash single quote world, it does not work. Double quotes. Double quotes are commonly used for enclosing strings. The characters of the string are preserved in double quotes, except for dollar, backslash, and backtick. Dollar, backslash, and backtick retain the special meaning. For example, X is equal to hello, echo $brace X prints the value of X, which is hello. Now, if we say Y is equal to double quotes $brace X, comma, space world, the shell looks inside the double quotes and replaces $brace X with the value of X, and we get hello, comma, space world. One interesting character is the backtick character. What is in between a pair of backticks is executed and is replaced by the output in the original command. For example, dir is equal to backtick open pwd backtick close echo double quotes working in directory $brace dir. This prints the present working directory. Instead of backticks, you can use the construct $parenthesis command, which does the same thing. For example, echo double quotes time is $parenthesis date and it prints the current time. Positional parameters. What happens when you run a bash script? I have a bash script named hello and I execute it from a terminal window. The process executing the bash script is PID 8807. As you can see, a new instance of bash is created. Then this has parameters .hello 1, 2, 3, 4, etc. From these parameters, positional parameters for the script are assigned. There is the name of the script ./hello and then the positional parameters. Positional parameters are $1, $2, $3, etc. and these are assigned from the parameters following the name of the script. The name of the script is $0 and the number of arguments is $hash. It is the number of arguments after the name of the script. Special parameters. $. $* expands to all positional parameters starting with the first. If there are no spaces in parameters, each parameter is a single word. However, if there are spaces in a parameter, it appears as multiple words delimited by space. When quoted, all parameters appear together as one word with internal field separator placed between parameters. So it appears like $1C, $2C, $3C, etc., where C is the first character of the internal field separator. $@ also expands to all the positional parameters. When not quoted, it is just like $. When quoted, $@ expands to all positional parameters with each parameter as a single word. This works even if parameters have spaces. $@ in double quotes is the preferred way to get all the positional parameters expanded with each parameter being a single word. $hash expands to the total number of positional parameters. $? Is the exit status of the last command executed. $- expands to the current value of the options flag. $$ expands to the process ID of the shell. $! expands to the process ID of the command most recently placed in the background. $0 is the name of the shell script for the non-interactive shells. For interactive shells, it is the command used to invoke bash. $_ expands to the last argument of the previous command. String manipulation. Since bash scripts deal with strings, we need string manipulation commands. Although string manipulation is done well with sed and awk commands, shell also supports certain string manipulation functions, and the interface for these functions is quite clear. First, the string length. We can find the string length with parameter expansion $brace hash string. So if str is I am a string, echo $brace hash str prints the length as 13. Substring extraction. If you have a string and you want a substring, you can use parameter expansion $brace string : position extracts the string starting at the given position. The string index starts at 0, and we can optionally specify the length of the substring with $brace string : position : length. For example, if our string is str is equal to hello world, echo $brace str : 7 prints world, and echo $brace str : 7 5 prints world without the exclamation mark. We can replace a substring in parameter expansion, which is like $brace string / substring / replacement, and the substring in the string is replaced with a replacement. For example, if we have a string str1 as apple, mango, guava, apple, pineapple, and we do parameter expansion of the string str1 with apple replaced by orange, we get orange, mango, guava, apple, pineapple. So only the first substring has been replaced. If we put / before substring, that is $brace string / substring replacement, this replaces all occurrences of substring with a replacement. So if we give this command echo $brace str1 / apple / orange, we get orange, mango, guava, orange, pine, orange. That is, all occurrences of apple have been changed to orange. If the replacement is not given, the substring is simply deleted. Echo $brace str1 / apple, and we get orange, guava, pine. It is worth noting that the original string is not modified. We can check that with echo $str1, and str1 is still unchanged. This is because we have used parameter expansion of str1 with some modifications. If we put hash before substring, the search happens from the front end. The first occurrence of apple from the left is replaced with orange. And if we put a %sign before the substring, the search takes place from the rear end, and the first occurrence of substring is replaced with a replacement. Removing substrings. When we expand parameters, we can remove parts of the resulting string, and here we have two possibilities. First, remove matching prefix pattern, and second, remove matching suffix pattern, which means that you can remove something at the beginning or at the end of the string. So first, let's look at deletion of substring at the beginning of parameter expansion, and we have $brace parameter hash word or $brace parameter double hash word. The word here is a regular expression, a sequence of characters expressing a substring. So if the word matches the beginning of a parameter expansion, the matching part is deleted, and resulting string is the parameter expansion. When there is single hash, matching is minimum, and with double hash, the matching is maximum. For example, file name is equal to somefile.ext, and we want to get the file extension. We can say echo $brace file name double hash star dot. Here star dot is the word which means match all characters before the dot, and since it is double hash, matching is maximum. So this results in matching of some file dot, that is all characters up to dot are matched and deleted, and only file extension ext is left, which is the resulting string. Similarly, if we have a full path name in the parameter path name and we just want to find the file name, we can say echo $brace path name double hash star slash. Path name is slash home slash user1 slash src slash shell slash somefile.ext. All characters till the last slash are matched and deleted, and the resulting string is somefile.ext. Similarly, we have the removal of suffix, the substring at the end of a string, and we have $brace parameter percentage word or $brace parameter double percentage word. The word is a regular expression and is matched with a string at the rear end. All the matched characters are deleted. Single percentage results in minimum matching and double percentage results in maximum matching. So if we say echo $brace file name percentage dot star and file name is somefile.ext, all characters starting from the dot to the end are matched and deleted, and we get some file. Similarly, if we say echo $pathname percentage slash star, all characters starting with the last slash to the end of string are matched and deleted, and we get the directory name from path name of a file. Now we come to commands. Commands in shell scripts are like statements in a program. Commands are the basic entities that make a shell script. A command can be a simple command, a pipeline, a list, or a compound command. A simple command is a command followed by parameters. For example, cat file1 file2. The return value of a command is its exit status. If a signal with number n terminates the command, the return value is 128 plus n. A pipeline is a sequence of simple commands connected by the pipe character. That is, command 1, pipe to command 2, pipe to command 3. The standard output of a command to the left of pipe symbol is connected to the standard input of the command to the right. And although it's not very common, you can use pipe ampersand symbols instead of just pipe symbol, and the standard error is also sent along with the standard output to the standard input of the next command. Pipe end is a shorthand for 2 greater than ampersand 1 pipe. The return status of a pipeline is the exit status of the last command if pipe fill option is not enabled. However, if you enable the pipe fill option with set-o pipe fail, the exit status of pipeline is the exit status of the rightmost command, returning a non-zero exit status. If all commands of a pipeline return 0 exit status, the return value of the pipeline is 0. Lists. A list is a sequence of pipelines separated by semicolon, ampersand, double ampersand, or double pipe. A list may be terminated by a semicolon, ampersand, or a new line. Double ampersand is a symbol for logical AND, and double pipe stands for logical OR, and these two operators have equal precedence. Ampersand and semicolon also have equal precedence. Logical AND and logical OR have a higher precedence than ampersand and semicolon. Commands separated by semicolon or new line are executed sequentially. The shell waits for a command to complete, and after the command completes, it starts the next one. If a command is terminated with an ampersand, the shell starts the command, does not wait for it to complete, and the command executes in the background. The return status of the command is 0. Now we come to the list with logical AND and logical OR operators. Here, a word about exit status of commands. The concept of true and false in shell is different from that in C programming. In shell, the exit status of 0 is regarded as true and a non-zero exit status is regarded as false. The logical AND and logical OR operators associate left to right. So in a list like command 1, logical AND, command 2, first, command 1 is executed and if and only if the exit status of command 1 is 0, that is true, command 2 is executed. And similarly, in the list command 1, logical OR command 2, first command 1 is executed and if and only if the exit status of command 1 is non-zero, that is false, command 2 is executed. The return status of a command list is the exit status of the last command executed in the list. Compound commands. There are 4 types of compound commands: parenthesis list, brace space list, double parenthesis expression, and double square brackets space expression. The spaces mentioned are necessary for the shell to parse the command correctly. List. When you specify a list in parentheses, a new shell called a subshell is created and the list is executed in it. So if you have a shell script named hello1 where there is a list in parentheses in the second line and we execute this, we get output similar to this. The first PS command executes in the subshell. You can see process ID 4265 for the shell executing hello1 and process ID 4266 is for the subshell. The subshell terminates and does not come in the second PS output. List. The second compound statement list in braces. Now brace is a reserved word in shell, so one has to leave space after brace so that shell can recognize it. Braces are used for grouping commands. The command list must be terminated by a semicolon or a new line. For example, we can have command 1 logical AND brace space command 2 logical OR command 3 semicolon. If and only if command 1 returns 0 status, command group brace command 2 logical OR command 3 semicolon is executed. Expression. And the third compound command double parenthesis expression. The expression is evaluated as an arithmetic expression. Only integer arithmetic is supported. For example, if calculate is a script with a is equal to 2, b is equal to 3 and c is equal to 4 and calculates the expression a star parenthesis b plus c, the value printed is 14. Expression. Now we have expression in double square brackets. And since double square bracket is a reserved word, it is necessary to leave spaces around it so that shell is able to parse it. Here expression is a conditional expression. The value returned is either 0, which is true, or 1, which is false. A conditional expression is made up of unary and binary primaries. The primaries check file attributes, compare strings, and do arithmetic comparisons. The primaries are -a file, true if the file exists, -b file, true if the file exists and is a block special file, -c, true if the file exists and is a character special file, and so on. And binary primaries, file 1 -ef file 2, true if file 1 and file 2 refer to the same device and inode numbers, file 1 -nt file 2, true if file 1 is newer than file 2 as per the modification dates. Also true if file 1 exists and file 2 does not, and so on. Minus z string, true if the string has 0 length. String 1 is equal to string true. True if string 1 is equal to string 2. String 1 not equal to string 2. Then numbers, number 1 minus eq number 2. Number 1 minus any number 2, true if number 1 is not equal to number 2, and so on. A primary is an expression. Expressions may be combined to give another expression. For instance, parenthesis expression. This returns the value of expression, not expression. If expression is false, it returns true. Expression 1, logical AND expression 2. This returns true if both expression 1 and expression 2 are true. Expression 2 is evaluated only if expression 1 is true. Expression 1, logical OR expression 2. This returns true if either expression 1 or expression 2 is true. Expression 2 is evaluated only if expression 1 is false. For example, assume we have a file named hello1 with set group ID on, and we have a script as shown here. First, x is set to string hello, and we have this if statement with conditional expression with two primaries connected with logical AND. The first primary checks for string equality whether string x is equal to hello. It indeed is, so that returns true, and the next primary is evaluated whether file hello1 has set group ID bit on, which is also true. So the then part of if is executed. So echo prints $, which is the exit status of the last command. It is true, so 0 is printed, and the next echo command prints the word true. Now we look at control flow statements, and the first is the if statement. It is if list semicolon, then list semicolon, square brackets, elif list semicolon, then list semicolon, square brackets close, and this can get repeated, square brackets else, list semicolon, square brackets close, fi. The elif and else parts are optional, and that's why they are in square brackets. Notice the semicolons, they are part of the syntax and hence required. However, you might use new line instead of semicolon. We have seen the use of if statement in an earlier example. If double brace $x is equal to hello and minus g hello1 double brace close semicolon, then echo $, semicolon, echo true, semicolon, else echo false, fi. Next, we have the case statement. It is like case word in bracket, left parenthesis, bracket close, pattern, bracket or pattern, bracket close, repetition, parenthesis close, list, double, semicolon, bracket close, repetition, ESAC. The left parenthesis is optional and is rarely written. The word is matched for each pattern, and for the first match, the corresponding command list is executed and the command completes. The vertical bar in pattern 1 bar pattern 2 means either pattern 1 or pattern 2. A range of characters can be specified in brackets, and a star can be used for matching all characters. The exit status is the exit status of the last command executed and is 0 if no pattern matched. The double semicolon separates a pattern and its command list from the next one. Here is a small script which tells whether to work or play based on the 3-character code for the day of the week. So, if the day is Sunday or Saturday, play; on the rest of the days, work. And if there is no match, we have error in input. There are two forms of for loop, the traditional shell form and the C style. This is the traditional shell for loop, and it is for name, bracket, in bracket, word, repetition, bracket close, semicolon, bracket close, do list, semicolon, done. The part inside the brackets is optional and semicolons can be substituted by new lines. First, the word is expanded. The name is assigned to the first word in the expansion and the list is executed. This is repeated for all the remaining words in the expansion and the loop terminates. The return status is the exit status of the last command executed. Let's look at an example. This is a script named forCheck to illustrate the traditional shell style for loop. For name in star expands to the names of all the files in the directory. Name is assigned to the file names one by one and each name is printed in the for loop. Now in word is optional in the for loop, so if we delete in part, the for loop prints positional parameters. So we delete the in part and we run the script with some arguments for check 1 2 and the for loop prints the positional parameters. Suppose the word expands to an empty list. Then the for loop executes 0 times, that is, it does not execute at all. So we say for name in $x and x is not set, so it expands to an empty list and there is no output. This is a C style for statement. expr1, expr2 and expr3 are arithmetic expressions. First, expr1 is evaluated and then expr2 is evaluated. If expr2 evaluates as 0, the command is complete. Otherwise, the list is executed. After executing the list, expr3 is evaluated. The sequence evaluate expr2, execute list, evaluate expr3 goes on till expr2 evaluates as 0. If any of the expressions expr1, expr2 or expr3 is missing, it is assumed to be 1. For example, we have the script for generating 5 random strings and when we execute it, we get this output. The while command executes list 1. If the last command in list 1 has an exit status 0, list 2 is executed. This is repeated till the last command in list 1 returns a non-zero exit status. And we have an example here. List 1 is the conditional expression that returns 0 as long as counter is greater than 0. So when counter becomes 0, list 1 returns a non-zero exit status and the while command is over. The until command is just like while command except that list 2 is executed till the time last command in list 1 returns a non-zero exit status. So here, once counter becomes 0, list 1 last command returns a 0 exit status and the until command is over. The select command can be used for presenting a text-based menu to the user and executing a list of commands corresponding to the option chosen by the user. The word is expanded and all words in the expansion are presented in a menu on standard error with each preceded by an option number. The user is prompted to choose an option with PS3. Based on the option chosen by the user, the item value is assigned to the name which can be used by the commands in the list. Here is an example of select which allows the system administrator to monitor processes run by the users. We find the currently logged in users with a who command. To this we append quit, the option to end the script. We set the prompt PS3 to select user and the heading is find processes being run by a user. Select user in $users. So $users is expanded and is displayed with option numbers on the standard error. User is assigned the value corresponding to the particular user in the $users expansion. And for that user, the command ps-f is run. If the operator chooses an option outside the range, $user is a null string and we print error input, please try again. And we come to the end of this video. You can find all this information at https://tinyurl.com/script7. Please subscribe to my channel. Thanks very much for watching. Take care and stay safe.